Hello, and welcome to this first of 4 videos on set fundamentals. This is a series in quantitative reasoning, and we're starting with the topic of sets. So there are 4 videos that go through this section of the text, and this is the first of them. Now let's take a look at what it is we're going to learn here. So in these 4 videos, our learning objectives are these. You're supposed to be able to represent a set using a written description and the roster method, and you'll see that what you use to surround the list is important and how you write the list is important. We're going to also learn about set builder notation, which is a shorthand instead of doing roster notation. We're going to identify the cardinal number for a set, and that sounds really fancy, but it's just how many things are in the set. And then we're going to determine if 2 sets are equivalent. And in order to determine if 2 sets are equivalent, we need to know their cardinal number. And then the last thing is a little stronger indication of the likeness of 2 sets are if they're equal. So this won't all be in this first video. These will be in the 4 videos for this section. So first, let's look at writing using a written description and the roster method. So when we do this, we need to know, what is a set? Well, a set is just a collection of things or a group of things. The people in this class could be the set of class members in Math 140 section, whatever this is. The people on a team could be thought of as a set. The set of people that make the team is the roster of the team. So we're going to take a look at sets, and we're not just going to write things in sets. That's actually fairly simple, but we're going to talk about how sets relate to each other, how they overlap with each other, and we're going to use them to understand relationships between these groups and to analyze data. So any collection or group of items can form a set. It's defined as follows. It's a collection of or group of distinct objects called elements of the set. Now, if you go into higher level mathematics and more abstract math, it gets a little more complicated than that, but for us, this is fine. It's a collection of objects or things or distinct objects. Distinct meaning that if something occurs twice, if it's a set of numbers and the number 3 shows up twice in whatever you're doing, you would only write the 3 down once. Distinct, you would only write the different types of things in the set. So how do we write these in what is technically the roster method? So it's important here that we pay attention to details. And if you don't pay attention to the details, you're not going to have written this in the roster method. We can define a set by listing, so it's a list of elements enclosed in curly brackets. A curly bracket looks kind of like this. There's one end of the left curly bracket and the right curly bracket. And you can see I don't draw them perfectly, but it is also a key on your keyboard. It's next to the letter P. I think that's universal. It's on my keyboard. The 2 keys next to the letter P, you would have to shift to get them. It's above the square bracket. But this is called curly brackets or set braces or set enclosure. So you list each item in the set separated by commas. So you would just list all the names of the people in the class separated by commas, and you would put them in between that list, in between those curly brackets. This is called using the roster method. So a written description, I've been using a description, the set of people in the class, the members of the team, that's a description of a set. So we need to be able to go from a description to the roster. So if the elements of a set just tell you what's in the set's contents, the order doesn't matter. So it wouldn't matter what order I listed your names in if I were listing the set that represents the class, as long as every name was there once and only once. And notice, here are your braces, your curly braces, and here are separated by commas. So this is the set containing the elements 1, 2, and 3. And it is the same as a matter of fact, we'll learn that these sets are actually equal. The set containing 3, 1, and 2. The order doesn't matter. It's one of the few places in math where order doesn't matter. So, and there's also possible to have a set that has nothing in it. A set that contains no elements is called the empty set. For example, the set of numbers that are both larger than 10 and less than 5. Well, there's no number that's both bigger than 10 and at the same time less than 5. That would be the empty set. So you can either write those as the curly brackets with nothing in it, or this symbol here. The symbol is an O with a line through it. But do not do this. This is not the empty set. This is the set containing the symbol for the empty set, and it's not empty. It actually has one element. So you can either write it with an empty, most people tend to use this. That's what the empty set is. But that would be a set that has no members. So it's also helpful to be able to name sets. We commonly use a letter to represent the set in order to make it easier to refer to later. And I know you're thinking, oh no, here we go with X. This is the same kind of thing. It's a placeholder, but really it's easier to refer to if I want to talk about the set containing the elements 2, 4, 6, 8, and 10. It's easier to define it once. Now I can just say set E. So for instance, this set says set E equals the set containing 2, 4, 6, 8, and 10. Then I have a symbol here that's introduced, and you'll have a list of symbols that you'll need to learn. And this one is actually pretty straightforward because it looks like an E. It's just kind of rounded off. It means is an element of. An element of is something that belongs to the set. So each person in the class would be an element of the set containing all the members of our class. Each person on the team would be a member of the set containing all the team's roster. In this case, the number 4 is an element of set E because it is in set E. Don't make that more difficult than it is. It just means it is in the set. So if I want to say 4 is in set E, I could write it very concisely like that. And in math, we've been speaking in English language using words, but in math, we tend to turn those words to symbols so they don't have multiple meanings. Math is kind of an international language, and that's why you're going to see so many symbols in this course. You're going to see a lot of symbols in this course, probably far more than you've seen in any algebra. Well, it will be far more than you've seen in any algebra-based course. Just a lot of new symbols and vocabulary. There's not a lot of really high-level, difficult stuff, but you need to know what these symbols mean. And the first one is the symbol for element. So let's practice one. Now, pretend we're not looking at the solution here. Let's use the roster method to list the elements of the set consisting of all odd numbers less than 10. Well, this is probably a good time to take a look at what makes a number odd and what makes a number even. So hopefully you remember this, but an even number is divisible by 2. What do I mean by divisible? And an odd number is not divisible by 2. Divisible by 2 means if I take the number and divide by 2, I have no remainder. I get an integer value. Integers are counting numbers in 0 and negative counting numbers. We don't get decimals. We don't get fractions. We get some of you will think it's a normal number. That's a terrible way to think about it, but we get an integer. And we'll talk about the list of integers and real numbers and things like that within this section too. So odd numbers would be all the numbers that are not divisible by 2. So it turns out any number ending in 1, 3, 5, ending in this 7 or 9 is odd. So not just the numbers 1, 3, 5, 7, and 9, but the numbers 11, 13, 15, 17, 19, 21, 23, 25, 27, 29. They are odd, but here I'm just asked for the ones less than 10. Now, if they had asked me for the ones less than 11, my answer would be the same, even though 11 is odd, because less than does not include the number they're talking about. That would have to say less than or equal to 11. But for the answer to this one, you see I've written my list, separated by commas, and then I put my curly brackets around it. So you can see the answer typed out below, but hopefully this explanation helps you see where that comes from. All right, and another example. Now this one doesn't really use as much math, but it assumes some understanding of some cultural literacy. Use a written description in the roster method to list the set D. So they're telling you to name the set D of all U.S. dollar bills, United States dollar bills, 100 and below. So the 100 and below means you're going to include the 100. So maybe you don't really know what these bills are, but I will tell you, hopefully, one, they included the two. Some of you are probably too young to remember when the $2 bill was a thing. It was a real bill that was printed many, many years ago. And then back in when I was a teenager, I think, probably, I want to say the 80s, somebody could look up the history if they're that interested. They started printing them again. I probably have a couple of stray $2 bills around. So I probably wouldn't have put that in the list if I were writing it, but we do have $2 bills that are still, I believe you can still pay for things with them because they're still real United States currency. So 1, 2, 5, there's a 10, there's a 20. There's no $25 bill, so the number 25 isn't there. Then there's a 50, then the next bill is 100. So you would have to know something about what bills are printed to do this. It's not something I would necessarily ask in a test. But the idea is a set doesn't have to be necessarily just mathematical numbers and that. It can talk about all kinds of things. So that's the roster method for writing a set. And it's fairly simple, but you have to be careful. You cannot just write, if you just write 1, 2, 5, 10, 20, 50, 100, this is not a correct answer. Without the brackets, without these brackets here, this is not roster method. And also it told you to list the set D, so you have to name the set D equals. So you have to be very specific about the details of your notation. That doesn't make this hard. It just means you have to be careful and practice it a little bit. All right, that is all for this part 1 of 4 videos on set fundamentals. And I will see you in the next video, or I'll see you in class too.